This video, we're going to be talking about how to compute powers and radicals without using a calculator. When you're doing this, one thing that's kind of handy to keep in mind is it's useful to know some of the common powers. So specifically 2 and 3, right? If I have 2 to the x and 3 to the x, and I just want to start listing powers of each of these. For 2, right, 2 to the 0 is 1, that's true for both. Then 2 and 3, and then 2 squared is 4, 3 squared is 9, and then, I just keep going, right? So then I have 8, 16, 32, 64, 130, 130, oh dear, 128, and so on. For 3, I'm just thinking about 3s. For 3s, we have 9, then 27, then 81, then 243, and usually for 3, we don't really get up higher than that. Okay, so let's say I want to evaluate 8 to the 2/3. Normally, you might be inclined to plug this into your calculator, but I'm going to show you how you can do it without doing that. What I'm going to do is I'm going to show you kind of 2 ways to think about this. One is, let's start with 8 to the 1/3 squared. So I'm using the power property here to split these up, right? So I'm going to say, okay, well, do I know the cubed root of 8? Yes, I do, because I know 2 to the 3rd is 8, so the cubed root of 8 is 2. So now I have 2 squared, and 2 squared is 4. Alternatively, I could do 8 the other way, right? 8 squared, and then the cubed root. So 8 squared is 64, and then the cubed root of 64, and this is where, you're less likely to know. This is where if we kept going, right? 4 to the x, it'd be 1, 4, 16, and then 64. So the cubed root of 64 would be 4. If you ever are doing these and maybe you started with the second way and you said, okay, 8 squared is 64. What's the cube root of that? I don't know. Then you could always try rewinding, backing up, and just switching to this method and saying, okay, well, maybe can I get to the cubed root of 8? Do I know that? Because if I know that, then it's relatively easy to square it. Okay. Let's say I want to do another one. Let's say we have 216 raised to the 4/3 power. This one looks even crazier. This is not a nice power of 2 or 3. But what I'm going to do is I'm going to factor this. Okay. So think back to middle school where you would factor numbers and you'd write them as primes, right? And when you had a factoring tree and you wrote all your primes out. So I can factor this into 2 to the 3rd times 3 to the 3rd. That's equal to 216. And you can do this yourself with a factor tree. So, okay, well, 216 is, 2 times what equals that? Okay, and then I can break that factor up and keep going. So now I have 2 to the 3rd times 3 to the 3rd, all raised to the 4/3. I can distribute this into each of the powers here, right? And when I distribute this in, I use my power to a power rule, and I get that this is equal to 2 to the 4 times 3 to the 4, because 3 times 4/3 is going to be 4. So when I do that, I get 16 times 81. Oh, I wrote 18 for some reason, though I said 16. Yeah, this should be 16 times 81, and that will give you 1296. And that is 216 raised to the 4/3 power. Okay, we'll do one more here. Let's say I want to find, maybe I want to do the 6th root of 256 divided by the 4th root of 64. Okay, so what I'm going to do here is I'm going to rewrite these as fractional exponents first. So I'm going to have 256 to the 1/6 power divided by 64 to the 1/4 power. But I can't do anything with this because these bases are different. I need the bases to be the same in order to do any kinds of exponents rules that we talked about previously. So I do notice these are both powers of 2, so I'm actually just going to rewrite these as powers of 2. So 256, if I kept going, this is 5, 6, 7, 8 is 256. 256 is just 2 to the 8th. So I have 2 to the 8th to the 1/6 power divided by 2 to the 6th to the 1/4 power. And then I can use my exponent rules, and I have 2 to the 8/6 divided by 2 to the 6/4. Okay? And I can simplify these to be 2 to the 4/3 divided by 2 to the 3/2. And then 4/3 minus 3/2, right? If I'm doing 2 to this over 2 to this, gives me my answer, which is 2 to the negative 1/6, which I could also write as 1 over 2 to the 1/6, or I could write as 1 over the 6th root of 2. Okay, so this is how you can manipulate radicals and powers and do some calculations that initially might look quite difficult without ever picking up a calculator.